In this screencast, I'll be going over minimum margin MIRA. And so basically we've gone over the idea of this in the two-class case already in the previous screencast. And basically the idea was to do a little bit of extra rotation whenever we had a point so that we would end up doing the right amount of rotation to get the maximum margin. And we did some approximations and we got this, which is basically MIRA with a minimum margin for two classes. So now we're going to do the general case as they presented it in the paper. This is a theorem from the paper. And so basically we're replacing my.x, which means the y vector dot x, with my.x minus beta. And so we're artificially making that dot product smaller, which means that whenever the margin my.x minus mr.x, whenever that margin is less than beta, this now will be negative, and so we're going to do an update. So with that small modification to the previous algorithm, now we have a minimum margin MIRA. And so by margin here, we mean my.x bar minus mr.x bar. We're going to try and make this greater than or equal to beta for all r that are not equal to y. So that's what we mean by minimum margin. Note that if x is a large vector, this could correspond to a very small margin in terms of distance, right? Yeah. And so they've got their notation for basically saying that same thing. They've replaced their b with this b tilde, which has, in the case that y is r, we have minus beta. And so that's the basic idea. Hopefully that makes sense. Where I have some issue with the paper is when they start talking about convergence. So they say that we apply theorem 9, replacing beta with beta tilde. Now, in deriving this bound here, I believe that we assumed something about the update, that the update was always smaller than r squared. However, now we'll be doing some updates. I guess this may not apply. Because now that we've got this minimum margin, the updates in the two-dimensional case, the updates always have a component in the right direction and then a component perpendicular. And then when you have perpendicular or worse than perpendicular. And when something's like that, in terms of length, the worst case is that the squares add. And so that's how we got a bound on, we got the norm of m was less than the number of updates, less than k r squared. I'm not sure if this applies, and so I'm not convinced that the previous proof works now that we have a minimum margin. So yeah, I don't necessarily buy this. However, I'm pretty sure that MIRA converges because as initially, because of the minimum margin, the size of our vector x, the size of our vector might grow fairly quickly. But once the size of the vector x is large, then this extra term doesn't really matter much, right? Because if x is large, this will tend to be way bigger than this. And so this doesn't really matter much, and then so we're close to back to the original MIRA. And for the original MIRA, I definitely know it converges. So I definitely expect that MIRA converges, but I'm not convinced that that you can just generalize theorem 9. At least they haven't shown me enough work to convince me. Yeah, so here I say since updates no longer occur when there is a mistake. And it was if there was a mistake, then we got something like this condition. If there isn't a mistake, but we still do an update, then maybe this condition doesn't apply, which was part of our proof, which gave us that. So I did a bit of the work here. Each time we do an update, just like before, this dot product increases by that. So our matrix is in a way becoming, it has more and more components in the same direction as this. And then I just look more generally at all the updates, and this is what I get for all the updates. We just get this extra term here. But yeah, I found it somewhat difficult to analyze rigorously, and I don't want to put too much time into it because I'm sure it works. And this has probably been done already anyways. That's it. So the key idea here is, once again, this modification of adding a minus beta in where we've got the dot product of the vector y with our point. And with this minus beta added in, there will always be an update whenever the margin between these is less than beta. Thanks for watching.